Hey there, and welcome to Manufacta. Today, we're diving into the world of self-healing materials. Ever wish your phone screen could fix its own cracks? Or your car could mend a dent on its own? That's the incredible future these materials promise. Imagine a world where things last longer, reducing waste and saving resources. That's the power of self-healing technology. Now, before you picture robots stitching up buildings, let's break it down. Self-healing materials don't wave magic wands. They use super cool science to repair themselves at a microscopic level. Think of it like our bodies. When we get a cut, our skin repairs itself. These materials work similarly, but instead of blood cells, they use tiny capsules, special networks, or even their own molecular structure to heal. It's like having a built-in repair crew at a microscopic level. This isn't just sci-fi anymore. Scientists are already making huge strides in this field. From self-healing concrete and bridges to phone screens that fix their own cracks, the possibilities are mind-blowing. So, buckle up as we explore the fascinating world of self-healing materials and how they're changing the future. Get ready for a wild ride into the future of materials science. Okay, science enthusiasts, let's get down to the nitty-gritty. Today we're diving into the fascinating world of self-healing materials. These are not just any materials, they have the extraordinary ability to repair themselves, much like how our skin heals after a cut. Intrigued? Let's explore how this magic happens. How do these incredible self-healing materials actually work? It's a blend of cutting-edge science and a bit of creative genius. Well, imagine a tiny world inside the material itself. There are different approaches, but they all share the same goal: to fix damage before it becomes a big problem. Think of it as a built-in repair system, always on alert. One way is to embed the material with tiny capsules filled with a healing agent. These capsules are like little emergency kits, ready to spring into action. Think of these capsules like microscopic repair kits. They are strategically placed throughout the material, ensuring that no crack goes unnoticed. When the material cracks, these capsules break open, releasing the healing agent. It's a bit like popping a blister, but in a good way. This agent then reacts with the surrounding material, effectively sealing the crack. The reaction is quick and efficient, making the material as good as new. It's like having a million tiny doctors on standby, ready to patch up any damage. Imagine an army of microscopic surgeons working tirelessly to keep the material intact. Another approach uses a network of tiny channels, similar to our blood vessels. These channels are intricately woven into the material, creating a complex network. These channels are filled with a healing agent that flows through the material. It's a continuous flow, always ready to address any damage. When damage occurs, the agent is transported to the site of the injury, where it reacts and repairs the damage. It's a bit like how our blood clots to heal a wound. It's like the material has its own internal plumbing system, delivering healing power wherever it's needed. This system ensures that the healing agent reaches even the most remote cracks. These are just two of the amazing ways scientists are creating self-healing materials. The possibilities are endless, and the potential applications are mind-blowing. It's like giving materials a little bit of life, allowing them to heal and regenerate. Imagine a world where buildings, bridges, and even electronic devices can repair themselves. Now let's explore these methods in a bit more detail, shall we? We'll delve into the science behind these innovations and see how they are being applied in real-world scenarios. Get ready to be amazed. The future of material science is here, and it's more exciting than ever. Stay tuned as we uncover the secrets of these tiny helpers inside. Let's zoom in on the capsule approach, shall we? Imagine a material filled with tiny capsules like a sprinkle of magic powder. These capsules are filled with a special healing agent, kind of like a liquid bandage. Now, when the material cracks, it's like popping a tiny balloon. The capsule bursts open, releasing the healing agent into the crack. This agent then gets to work, reacting with the surrounding material to seal the crack. Think of it like glue, but way more sophisticated. This approach is especially useful for materials that experience localized damage like small cracks or scratches. It's like having a team of microscopic repair crews stationed throughout the material, ready to jump into action at a moment's notice. The type of healing agent used depends on the material and the desired outcome. It could be a polymer, a resin, or even a special kind of bacteria. That's right, even bacteria can be used to heal materials. This approach offers a targeted and efficient way to repair damage, extending the lifespan of materials and reducing waste. It's like giving materials a second chance. Pretty neat, huh? Vascular network approach, inspired by nature's genius. Now let's dive into the fascinating world of the vascular network approach. This innovative method is revolutionizing the way we think about material science and engineering. Remember how our bodies have blood vessels that transport nutrients and oxygen? These vessels are crucial for maintaining our health and repairing injuries. Well, scientists have been inspired by this natural system to create self-healing materials with their own network of tiny channels. These materials can autonomously repair themselves, much like how our bodies heal wounds. These channels, often called microvascular networks, act like miniature pipelines running throughout the material. They are meticulously designed to ensure that the healing agent can reach any part of the material that gets damaged. They're filled with a healing agent that's ready to be deployed whenever and wherever it's needed. This agent is specially formulated to react with the material and seal any cracks or breaks. When a crack appears, the healing agent is released from the network into the damaged area, just like blood rushing to a wound. This immediate response helps prevent further damage and maintains the integrity of the material. Once the healing agent reaches the crack, it gets to work, reacting with the surrounding material to seal the damage. This process can happen in a matter of minutes, restoring the material to its original strength. This approach is particularly effective for larger-scale damage or damage that occurs over a wider area. It ensures that even extensive damage can be repaired quickly and efficiently. It's like having a built-in irrigation system for healing, ensuring that every part of the material can be reached and repaired. This analogy helps us understand how the healing agent is distributed throughout the material. The vascular network approach is a testament to the power of biomimicry, where engineers and scientists look to nature for inspiration to solve complex problems. By studying natural systems, we can develop innovative solutions that are both effective and sustainable. By mimicking the intricate systems found in nature, we can create materials that are not only stronger and more resilient but also more sustainable and environmentally friendly. This approach reduces waste and minimizes the environmental impact of manufacturing processes. It's a win-win for everyone. The development of these self-healing materials represents a significant advancement in material science, offering numerous benefits for various industries from construction to aerospace. The future looks bright with these nature-inspired innovations leading the way. Intrinsic healing molecules on a mission. Hold on to your hats, science fans, because things are about to get really small. We're diving into the fascinating world of molecules and their incredible abilities. We're talking about intrinsic healing, where the material itself has the amazing ability to heal without any external help. Imagine a world where materials can fix themselves, just like living organisms. It's like magic, but it's all thanks to some clever chemistry. Scientists have engineered these materials to have special properties that allow them to repair damage autonomously. In these materials, the molecules are designed to be reversible. This means they can break apart and then reattach, kind of like Lego bricks at a molecular level. This reversibility is key to their self-healing capabilities. Just like how you can take apart and reassemble Lego bricks, these molecules can detach and then come back together. This process allows the material to recover from damage and maintain its integrity. So when a crack forms, the molecules near the damage can actually rearrange themselves to close the gap. This self-repair mechanism ensures that the material remains strong and functional over time. This process can be triggered by heat, light, or even pressure. Different stimuli can activate the self-healing properties, making these materials versatile and adaptable to various environments. Imagine a scratch on your phone screen disappearing just by rubbing it. This is the kind of everyday application that could revolutionize our interaction with technology. That's the kind of futuristic potential we're talking about with intrinsic healing. These materials could lead to innovations we can only dream of today. It's like the material has its own built-in repair mechanism, constantly working to keep it in tip-top shape. This built-in resilience could drastically reduce the need for repairs and replacements. While still in its early stages, intrinsic healing holds enormous promise for creating materials that are incredibly durable and long-lasting. Researchers are continuously exploring new ways to enhance these properties. It could revolutionize industries from aerospace to electronics, leading to products that are lighter, stronger, and more sustainable. Imagine airplanes with self-healing wings or electronics that can repair themselves. Get ready for a future where scratches and dents are a thing of the past. The potential applications are endless, and the impact on our daily lives could be profound. As we continue to push the boundaries of material science, the dream of self-healing materials is becoming a reality. The journey of these molecules on a mission is just beginning, and the possibilities are truly exciting. So, stay tuned, science enthusiasts, because the world of intrinsic healing is set to transform the way we think about materials and their capabilities. The future is bright, and it's full of self-healing wonders. If you found this video interesting and want to discover more about how things are made, built, explored, discovered, or manufactured, be sure to give this video a comment, a like, and subscribe to Manufacta.